Right, good evening, everybody, and welcome to our first PRISM webinar in November. I still can't believe where the year is going, but we are where we are. And tonight we are back to a more normal webinar. Obviously, the last couple of weeks we've had some different topics brought to you, not sort of, they obviously were linked to farming, but not actually linked to the your day-to-day, what you're doing on farm and production wise. And tonight we've got some guys from Chuggers here to talk you through some of the work they've been doing. So Ed's going to talk you through his presentation, and then there is also a couple of his colleagues, Paul and Mark, there also, which may come in possibly for some of the questions. Chuggers have done a lot of trial work in the area of multi-species swards and grass and clover swards for beef production, and so I look forward to hearing about the research and the findings, and obviously sharing that with the PRISM guys. So I'll hand over to you, Ed. Oh, and if we can just if you've got any questions, either type them in the chat or write them down so you don't forget, and we will do all the questions at the end today. But do obviously raise your hand if you have got a question, and we'll bring those in at the end, if that's okay with everyone. So over to you, Ed. Thank you very much.
Okay, Katie, can you hear me okay?
Yep, we can hear you fine. Thank you.
Okay, thank you. And thanks for the invitation on behalf of Paul and Mark who are logged in, and myself. Thank you for the invite. Also to maybe acknowledge our colleague David Kenny and Alan Kelly, who's in UCD. And then we have two PhD students, Sarah Burke and Maria O'Rourke, who are part of this work. So we acknowledge their contribution. Okay, so we're going to speak about the work here at Grange on our grass clover and multi-species swards for beef production. And maybe there's some context to where we are, where we've come to. So we recognise that probably over the last 100 years, perennial ryegrass has been the dominant grass species that's sown. And I guess we know that ryegrass swards have responded well to high levels of chemical nitrogen. But I guess over the last decade or so, the place for high chemical nitrogen inputs, not to mention the cost of chemical nitrogen by itself, means that we might begin to question that road of high inputs in terms of chemical nitrogen on these swards. So recognising then that over time, while grazed pastures or dosage pastures are seen as being relatively cheap, they have got more costly over time. So that we also know then that the use of clover has the capacity to fix atmospheric nitrogen, and in doing so, it has the capacity to allow us to reduce the input of chemical fertilizer in terms of chemical nitrogen, and in doing so, hopefully reduce the cost of production. And in doing that, now we also know then that if we have low inputs there's someone else coming on the line there, I think.
Let me just
so also where we have low inputs of chemical fertilizer and we add clovers to these pastures, we know that we'll get increased herbage production. As well as that, we know that when we include clovers in our swards, we enhance or increase the nutrient value of those pastures. And also the work over many years, and did more recently here at Grange again, is ongoing at the moment. We know that if we include clover into a ryegrass pasture, we're seeing an increase in individual animal intake and also an increased performance in those animals. So we're now saying then that looking currently into the future, we see a clover-based sward as being the new norm or the new baseline. So we don't envisage, and you'll see it as we go through this talk, our approach is that grass clover is the new norm or base against which we're going to compare other things. So we have the idea of a grass clover sward being sort of in our mind for a long time in terms of a strategy. And then maybe the question can be asked, if we add other components to the swards, we'll call them the herbs. Now these plant species may have different growth habits. So they may have a different rooting zone. They may be able to tap water at lower levels. They may be able to tap into nutrients at a greater depth that maybe grass or clovers might not be able to do. Or indeed, these plants may have a different sort of architecture, standing up, looking into the sky, that might not necessarily be competing with grass per se for light. So if that was the case, then we might say, could these plants have a role? And I guess that brings us to the last bullet on this slide there. So really, if we add herbs to the clover and grass swards, let's call them diverse swards. Is there a role for those swards currently and in the future? And I suppose if we say that in the past we said grazed pasture was our cheapest feed source, now if we begin to replace some of the nitrogen that's used in those grazed pastures with clover, we're saying we're going to reduce the cost of that feed accordingly. So maybe then to try and put some context around this concept of complex swards and how they emerge. If we take this example where we have, let's say, 4 different sward components grown separately. We've got perennial ryegrass, PRG, and let's say we've got cocksfoot, white clover and red clover, and they're grown under one, say, common management strategy. Then the average yield for those, let's say, is what's there in black. It's the average of all the 4 put together. Now, however, if we take those 4, the ryegrass, cocksfoot, white clover, red clover, and we sow them together in one mixture, we will find invariably that the yield of the mixture is better than the best individual when grown separately. So we're getting something for free. We're getting some benefit of the mixture. So there is some complementarity or synergies taking place in these pastures that, can we actually tap in? If we get something free or for nothing, that's to be looked at and taken seriously. Likewise, we might look at this presentation here, where on the left-hand side, where we have the blue bars, we're looking at a pure sward of perennial ryegrass that's been cut for silage over the season for harvest being taken. And we see that at 0 nitrogen input on the bottom axis, we see a yield of short of 6 tons per hectare. When we increase that to 120 kilograms of N, we get a nice jump in yield. And when we put more nitrogen on, the next increment of yield is a bit smaller than the first increment. And when we actually put the third increment on, the actual response is actually smaller again. So we're saying then that at low levels of nitrogen, obviously the grass needs something, and when it's fed with nitrogen, we get the increased yield. Now we go to the next chart, the next histogram shown in green, and to our ryegrass sward, we're going to add, let's say, white clover and red clover. And when we do, what do we see? We see where we have low nitrogen or 0 nitrogen input or low levels of nitrogen input. By adding the legumes to the sward, we see a big jump in herbage production. So this is where we're seeing that many occasions the greatest response to adding extra components to the sward is where we have lower levels of nitrogen being used. And we go to the third part of this slide where we're adding chicory and plantain to the mixture. And we see again, we get a small increase in yield, additional yield to the addition of chicory and plantain. But the biggest step of all was got in the green, where we added the white clover and red clover. So then the concept is that maybe that these multi-species swards, in particularly those that are going to be driven by the clovers, are probably most interesting when we look at them at the lower or almost low levels of nitrogen being inputted.
Edward.
So then most of this background work though has been done on, we're going to call small plots where, these treatments are done and maybe animals might never set foot on them. So then that led us to our work where we're looking at a grazing study, where we're looking at the effects of pasture type on herbage production, animal growth rate, and the corresponding carcass attributes in late maturing steers from the suckler herd. And we're buying these weanlings in the autumn time and we're taking them through to beef. So we're working in the context of a suckler beef system. So basically our approach is we have 2 pasture types. I'll explain better in a moment. We have 2 pasture types. The cattle on these pastures are taken to 3 slaughter ages, and the cattle we have are also selected for certain degrees of fatness. We call it a breeding value for fatness. So what do we have then? Our 2 swards, our multi-species sward, I'll explain that in a moment what it is, and the grass clover sward. So 2 pasture types. Our grass clover is our new norm, and our multi-species what we're comparing with. Then we said we have 3 slaughter ages, so we're slaughtering at 19 months of age, which is basically at the end of the second grazing season for the animal. They're 19 months old. They're basically spring-born animals. We have more that are slaughtered at the end of their second winter at 23, 24 months of age. And we have a small cohort we're looking at that they'll go back to pasture for a short grazing season at the end of the winter. So they're not finished during the winter, they go back to pasture. And then, as I said, these animals have been genetically selected for high or low carcass fatness. So for the time we have available, and the last thing is, from these pastures, we're interested in the grazing component and the conserved feed, i.e. the size that's been produced from these swards. But for the time available this evening, for the half an hour or so we have, we're going to mainly focus on presenting the data we have from our 2 pasture types. So we're looking at the production from our multi-species swards and grass clover swards. So what did we want to do with our study? We wanted to look at animal growth, the intake of these animals, and obviously the carcass characteristics of these animals, which are late maturing suckle-bred steers, and they're coming off 2 pasture types, a perennial ryegrass white clover sward or a multi-species sward. And again, in a second, I'll explain what those multi-species pastures are. On the swards themselves, we're interested in quantifying what are the yield differences or similarities in these pasture types. We're asking, Mark is in. That's inside. There's someone here in the back. Thank you, Mark. If I click on it, that.
I'm not sure. Maybe.
Sorry, Mark isn't giving help. I've lost it all. Hold on. Bear with me now. That was a bad move. Share.
So if you just go to share screen again.
Yeah.
And hopefully you could maybe click on the icon where I was at the bottom of the screen, and if you can flick it to your other screen.
Let's see now. Can we get it, Mark? We're in trouble again.
It's totally different.
That's totally different now. So down mode. And we were in a full flight, you know. Now, where do we get back to? We definitely share, right?
Yeah.
Are you seeing that?
No.
Whoa. Okay. Like, where do we get to that? That's not down there anyway.
That's what we sure.
No.
Can't see anything. No. No, can't see anything.
I'll go back to it. Slideshow at the moment.
So if you click on the share at the top right, you should be able to then see if your presentation's open in presentation mode on the one screen.
That on my slideshow from the beginning.
You have to go into the share again. I said into the share.
Go on, click it actually, you find it.
Where's the share?
Share, right.
If you're in trouble, Eddie, I can try sharing.
Yeah, we just went half to the second ball. Yeah, we'll try one more here. Hold on now. Can you see that?
It's coming.
It's just coming up now.
Okay.
Yeah, then if you can just pop that in presenter mode.
Oh yeah, we'll try and make it if we can now. And from current study, but I go down to let's go all that. Can you see that?
Still in there.
It hasn't gone to presenter mode yet.
Is it okay? Give it a second.
I'll go down here. Is this where's this? We did this before.
Just here was it. Sorry about that now to all the listeners. Sorry about that.
It still hasn't gone to presenter mode yet.
Okay.
I think you need to go to slideshow at the top, and then even if you do start from the beginning, and then.
Oh, are you seeing anything now?
Still the same.
No, it's still just on your normal. It hasn't gone to presenter mode.
It's on presenter mode here now.
It is, yeah.
It's presenter mode on all our screens here.
So what you're seeing is the slide partially exposed, is it?
I'm not sure what it's done because it's just on the first. It's still on the first slide, but it hasn't gone into presenter mode.
Okay.
You don't have an option to switch screens now.
See. So we're obviously not
screens again.
Go on, yeah, go on. We're obviously not in the proper mode.
See, it's when you've both the watch calls open, I think. Where's the?
Just the presentation. Okay, that's that.
Things all work so smoothly when we tested it before, hey?
Oh yeah. But we won't panic yet.
Oh no. Where's this? Yeah, maybe Paul can share. Maybe.
Yeah, can you share, Paul? So to be fair, it might be easy to.
I can try that, yeah.
Sorry about that. Apologies. Can I work it in, Paul, from
that seems to be working now. Yeah,
what do we have now?
Can you see
that's
like
all.
what?
That's perfect.
Hmm?
So we're on grass production one. So if you can just scroll to the slide where Ed was.
Okay.
Oh, that'd be great.
Yeah, you can you see, Eddie, what I'm sharing?
Okay, I'm looking at my own screen now, so I have no idea what you have, Paul.
When you go to Teams, if you go back into Teams now, you should see what I'm sharing.
Oh yeah, yeah.
Grass production, is it?
Yeah.
Yeah.
Okay. So we need to go on 4 or 5 slides in, Paul. So thanks, Mark. Sorry about that. Okay. Guess we had all that done, yeah. We're here. We're at this particular point. That perfect stop there. So thanks. Apologies to everybody
Thank you.
we can't get back in. So we're saying we've explained what the animal part of the study is about. I've just lost it again. We're back in. Thank you. So on the sward type, so we have 2 sward types, perennial ryegrass and multi-species. And in terms of sward, we're interested in what about yields over time, the yields, absolute yields over time. What about the chemical composition or nutrient value of these pastures? And what about the persistence of the components in it? Secondly, we're interested in the broader nutritional and environmental aspects of this work. So we're interested in sort of determining intake, feed digestion, nitrogen balance, greenhouse gas emissions, in the animals consuming either these fresh pastures or conserved pastures. We're also interested in, we're aware that there's literature suggesting there's anthelmintic properties in some of these multi-species pastures. We want to maybe answer a question on that. And likewise, then we're aware of, they'd like to investigate that I'll call the bug population, the invertebrate population that's in these pastures, on ground, under the ground. We want to follow those as well. Okay, we can move on. Thanks. So, okay, so the approach we're taking then is that we have 2 pasture types, as I said. We have basically 14 hectares sown to a grass clover sward, and we have 14 hectares sown to a multi-species. Just to explain that in terms of the multi-species, we tried to establish in such a way that we had an equal plant population of the components. So we wanted to have an equal plant population of the grasses, an equal plant population of the clovers, and the same for the herbs, which we'll explain in a moment. So of the 14 hectares, or any of those, the 14 hectares is divided into 2. So there's 7 hectares given over to grazing. So on the map on the right, the area bounded in blue is basically the area that's grazed all the time. So half the farm is set aside for grazing, and the grazing area receives no chemical nitrogen during the year. So half the farm is for grazing, and the other half of the 14, which is 7, shown by the pink boundary there on the map, that's set aside initially for producing silage. So we'll have 2 harvests, so roughly half the farm is closed for first cut, and of that half, another 3/4 of that is closed for second harvest, second cut. And then when we have our silage, we are going at a reduced rate of nitrogen, but 75% of the normal rate is what we use. So to be clear then, on any given farm as such, we have 7 hectares for grazing all the time. The other 7 is for silage. After first cut, some of those silage paddocks come back in for grazing as to be needed. And when the second cut is taken, all the paddocks come back in for grazing, as would be in a fairly standard farming system. In terms of animals, what we have then, we have 72, as I said, late maturing weanlings or yearlings. They're typically 400 kilograms going out to grass in spring. And the 72 are arranged into 6 groups of 12. And the reason we have 6 groups is that we have 3 groups of cattle graze on the grass clover pastures, and 3 groups graze on the multi-species. When I say 3 groups, we run 3 small farmlets on each of the pasture types. Okay, so we end up having, in the first part of the grazing season, each farmlet have their own 10 paddocks to graze, and then there's an extra paddock or 2 added after first cut, and another few added after second cut. In terms of overall management, what we've done, we have set a post-grazing sward height of 5 to 6 centimetres. And in terms of managing the pasture, we do a weekly pasture cover where we walk all the paddocks and come back and estimate the supply of grasses on the block of land. Okay, Paul? And then we're saying then that the system overall then, the grazing area receives no nitrogen, but the silage area receives nitrogen at a lower rate. So the average input of nitrogen on our systems is 75 kilograms of N per hectare. And the next bullet should be that animal manures are returned to the silage area and not to the grazing area. So the idea is that we have two pasture types and their systems operating on those. Thanks, Paul. In terms of what do we sow then? So our ryegrass white clover sward is a mixture of late heading diploids. The varieties are Oak Park and Aston King. And we have late heading tetraploids, which is Meduno and Aston Energy. So they're fairly standard. And we have white clover, Crusader and Chieftain. So we've put 2 of each cultivar into our swards. The multi-species swards then contain the same low-lying perennial, but at half the rate. It contains white clover. The multi-species contains white clover at the same level of inclusion as the grass clover sward. But we're also adding Timothy, red clover, plantain and chicory. So our multi-species swards has grasses, clovers and plantains. So plantains, herbs. So there's 3 functional groups. So in terms of establishing the swards that were sown in sort of summer of 2021, the land was not ploughed, it was burned off with Roundup, sprayed with Roundup, power harrow twice, pneumatic seeder used to sow the seed, rolled immediately afterwards, and it got fertilizer application of P and K and nitrogen at sowing. And then the grazing area received no further nitrogen after that. Just in terms of, on the left-hand side, we have some of the cultivars were used. I mentioned the ryegrasses already. Timothy was Comer and I call it Promise. White clover, Crusader and Chieftain, and the red clover is Spurt and Agill, and the plantain was Tuatara and Hercules, and the chicory was Commander and Puna. So that's the swards that we've actually sown. Okay. Let's go straight to the results. So we would look at then the establishment of the sward, something on the persistency and the quality of the pastures over time, both grazed and conserved. Okay, so in terms of establishment, then this is a slide of this one plot I'll show fairly continuously to give some continuity. So in July of 2021, we're looking at on the left-hand side the grass clover sward and the multi-species on the right-hand side. And then the following April, at the start of the first true grazing season, we have our grass clover on the left and our multi-species on the right. Easy enough to see, it's quite a different looking sward and the cattle are out on it. So to make the point is that swards were well established. Okay, then we come to maybe a story in pictures, and I'll come back in the next slide then to talk about it in more detail. So at the end of the first grazing season in September 2022, we see that multi-species on the right-hand side is quite evident and the grass clover on the left-hand side. Now we come back to these pastures then 1 year later, or more than 12 months later, in November 2023, the same picture from the same location with the trough in the middle and the telegraph poles in the background. And we see that multi-species sward has changed considerably. You see a few chicory plants to be seen in the foreground and not much else. And then when we look at this pasture in April of 2024 this year, we're seeing something similar to that. We're seeing most of the multi-species or the chicory and plantain have disappeared from the sward. Now we go to the next slide, which puts this in a bit more detail. Okay, so a busy slide, but let's talk through it fairly simply. On the left-hand side with the green and orange, we're looking at the grass clover sward. The green is the grass, the orange is the white clover, and the black on top is weeds. Make the point on weeds first of all. After 2 rounds of grazing in spring, virtually all the weeds are gone. So we won't mention weeds anymore after this. So we start in spring of 2022 at the start of the first grazing season with about 10% clover in the sward. And then as we go into May, June, July, and into August, we see the clover content increasing as we would expect in any situation like this. And our clover content in the first year reached 40% in the dry matter in that first year in August, and it stayed reasonably high for the rest of the season. Now we come to second year, where we come out in spring and we look at the orange overall, which is white clover. We see this a similar pattern of clover content emerging in the second grazing season of 2023, but that the clover content is about 2/3 of what it was in the first year. And then we have only a short window in 2024 before the study finished, and we see quite low levels of white clover in our pastures in 2024, to make the point that most of us here experienced 2024 as being quite a challenging year in terms of having clover in our pastures. So that's the change in the grass clover swards. We see the clover having a typical seasonal cycle, starting low, getting a peak in that sort of July, August, maybe September period, and then maybe shrinking back a bit towards the back end of the year. Now then we turn to the multi-species on the right-hand side. multi-species, multicolored. So again, we have the green is the grass. Now the orange is the white clover, red is the red clover, the yellow is the chicory, the blue is the plantain, and the black is the weeds. And again, like we said with the grass clover, after the second really grazing cycle, most of the weeds were gone as such that were there around sowing time. So we won't mention weeds anymore for the moment. So if we look again at the orange and the red, which are our clover components, if we look at the orange and the red in total and look at the size of the height of the bars, you'll see the height of the bars on the red and white combined is nearly identical to what we saw in the grass clover swards at the corresponding phase in 2022. So the clover went through a typical cycle, but we see it's the red clover is making the biggest contribution. Now we look at the plantain shown in blue, and typically 15 to 20% of the sward was plantain throughout the year, reasonably steady during that first year. But then we see in yellow, which is the chicory. So we started off with almost 40% chicory in the sward in April. And then from into May, June and July, we see that decreased down to around maybe 15%. And it stayed relatively low for the rest of the season. So we're seeing then, while the plantain had a reasonably consistent content, the chicory decreased considerably. Now, when we come out at the following grazing season in 2023, we see again the orange and the red. When you combine the two, they're broadly similar to the orange we see in the first chart in green. But what we do notice now is that the yellow has particularly shrunk considerably. So the content of chicory in our grey sward has diminished considerably, and that probably ties in with the photographs you saw in the last slide. And again, what's shown in blue is the plantain, and by and large, they're about half or less of what they were the previous year. And a quick snippet then of what happened at the beginning of 2024, we've seen the yellow and the blue, which is the chicory and the plantain, the content has gone down considerably. So what we're saying that there's a big change in the sward composition, and it's particularly strong evident in the multi-species where the chicory component has reduced considerably. Okay, Paul. Okay, so let's put some numbers on these then. So we have two production cycles really done in 2022 and 2023. So within 2022, if we look at the yield of herbage, this is grazing, where we're putting out zero nitrogen. We're saying that the yield of undergrass clover and under multi-species were not significantly different. So both pasture types in the first year under zero nitrogen, and that's what we're using as zero nitrogen on the grazing area, were similar. Likewise, the pre-grazing herbage mass, the post-grazing sward height, and the residence time inside in the paddocks while we graze them is broadly similar, within a small bit of leeway there. In 2023, what do we find? We found, first of all, that 2023 had yields that were higher than the previous year, but when we look within the pasture types, we found that the yields of both pastures, grass clover multi-species, were equivalent. And likewise, when we come down to pre-grazing herbage mass, which was considerably higher in year 2 than year 1, but within the year, both pasture types are similar, both in terms of pre-grazing herbage mass, post-grazing sward height, and residence time. So what can we say out of all of that? We're saying we do see year-to-year variation, overall in terms of overall production, but within the year, we see both pasture types performing broadly similar. And in terms of things like rotation length, post-grazing sward height, residence time, and so on, they're broadly similar within year for the same two pasture types. Okay. Something maybe the feed quality. So I just have 1 year up here for the moment, and we're looking at the dry market adjustability of these swards. So across the bottom with all the colours, they're the months of the year. And then we have PRG, which is perennial ryegrass, WC is white clover, RC is red clover, CH is chicory, and the last PL is plantain. And we've simply put across the screen a line showing 75 DMD, which you might say is not an unreasonable pasture quality to look at. And what does it tell us? It tells us really throughout the year, with the rare exception, most of the sward components were at an acceptable level in terms of sward adjustability. Maybe there in the red clover RC for the months of September, October were a small bit low, and maybe once or twice the plantain was slightly shy as well. But by and large, I'd look at that and say, look, over the season overall, most of the sward components had a fairly similar nutritive value as measured by digestibility. Okay, and the next slide then looks at maybe the sugar content of these pastures or these components. What the sugars are water-soluble carbohydrates. What do we see? As we'd expect, the perennial ryegrass, particularly in the first part of the season, has considerably higher sugars or soluble carbohydrates than the other components. We'd expect white clover, red clover to be quite low in soluble carbohydrates, and indeed the chicory and the plantain are not that much different. So that might come into play. We might discuss it later on in terms of the ease of ensiling of these swards. Okay, a bit more on these swards then. So we look at the crude protein content of these swards. Now that blue line should have been across to the right more. All we're saying is that we have a bottom axis now. We have the components again, but this time it's looking at the grazing cycle, cycle 1, 2, 3, 4, and 5. The left-hand side is grass clover. I was to make the point that the grass or perennial ryegrass was the same, whether it's under grass clover or multi-species. We're looking at the same basic crude protein content of the grass under both pasture types. And then we're saying we look at the clover. So the clover under grass clover and the clover under the multi-species, that's the WC and the RC. We expect and we'll find that the crude protein content of the clover component will be higher than the grass components. And then the chicory and plantain are somewhat maybe a bit intermediate compared to the grass, but broadly similar. And the next slide then maybe shows the ash content of the pastures. And the only point I have this to make is that we see the mineral content, if you wish, of chicory and plantain being higher than the other sward components. So that's the herbage content, okay? And then if we look at these swards for making silage, so each year we have two harvests, harvest 1 and harvest 2, and the yields from the grass in 2022, the yields under the grass clover and the multi-species are very similar for harvest 1, and for harvest 2 they're also quite similar. So really in the first year of this work we found that the ability of these swards to produce silage under a lower nitrogen regime, not a zero nitrogen but lower, are broadly similar. In 2023 we found that the multi-species had a lower first cut yield than the grass clover, and you see the number there, almost 1.5 tons of dry matter. But when it came to the second harvest, both pasture types were broadly similar. So I might take the liberty and maybe in saying that in that second year, I'm choosing to interpret the multi-species not being that different than the grass clover. You might disagree with me on that, but for the moment, will allow me have my spake on it. What else do we observe? We observed then that in the multi-species pastures, we see the dry matter content of the herbage overall is 2 to 3 percentage points lower. And in the context of maybe making silage, that is not insignificant in that these pastures will need a longer time to wilt to get to a given dry matter content. But having said all of that, from the work we've done so far, we found that that both pasture type, that is the grass clover and multi-species, were both preserved adequately for our requirements. Now, we did have an issue in the very beginning, I'll say it now, where in the first season, when we went to cut some of our chicory dominant pastures, we had difficulty in actually picking it up when it was green and wet before it was wilted. And the last point on that slide is that on average, I have it in italics because it's not exactly fully true. I'm saying from both pasture types, when the silage is made, we have broadly similar intakes for both pasture types, and animal performance under both silage types is broadly similar. I have in italics because I'd make the point that in the first year we had the animals in, there was a lot of bales made and the intake was a bit lower on the multi-species than it was on the grass clover, and that might be qualified later on. So then in terms of appearance, these pastures making silage are broadly similar. The only thing we see visually is that the multi-species silage is that bit darker. Other than that, we see no great difference. Okay. Now then, so moving on to the animal side of the story. We're going to look at animal performance both in the 2 years, and we'll summarize it here then. So in the first year, cycle 1 in 2022, over the 200-day grazing season that we were out, our performance on our cattle was just over a kilogram, so 1.15 to 1.2 kilograms live weight gain per head per day. From my time here at Grange, I've seldom seen performance that good over a long grazing season as that, so we were really chuffed about that. When those animals came indoors for the winter, and some of them are placed on silage and 4 kilograms, you see quite a low figure there. There's a story behind that, in that when we came into the shed that first winter, we were trying to allow animals for their gut fill to equalise, having come off those pastures, and there was over a month when those cattle were on a silage only diet. So I've included that time in the time frame for the winter. So the 0.69 is probably a bit lower than what it would be if they had access to those diets from the very beginning. But then we had some cattle that came in and they were destined to go back to grass for the short extra part of the grazing season. When they come in, they're there as stores, they get a kilogram of concentrates, and during that their second winter, they're growing for 0.5 of a kilogram live weight gain per head per day, which is quite satisfactory on silage only, and a kilogram of meat. So we're saying that both multi-species and grass clover are broadly the same. And when those few animals that are stored for the winter go back for a short, maybe 50 or 60 day grazing season, they're growing at 1.2-ish kilograms live weight gain per head per day, and that's the same for both pasture types. Now in cycle 2, which is 2023, so again we have weanings come in at the very beginning. They're offered 1.5 kilos of concentrates and their respective silages, growing about 0.5 a kilogram per head per day, which is what we'd expect on that type of a diet. Now then, so they go back out to pasture, and a figure here from the grazing season would contrast fairly sharply to what we saw the first year. So we have a figure here of 0.6 to 0.64 on the two pasture types. But inside that, there's a story. And the story is that from turnout in mid-March until the end of July, both groups of animals were growing at 0.95 of a kilogram live weight gain per head per day. But then for all of August, all September and all of October last year, the cattle all stood still in very bad weather, and we got no additional live weight gain for those 3 months. So when I take the whole 200-day grazing season and work it up, we get a live weight gain of only 0.6 or 0.64, which is the same for both pasture types. Then when those cattle go indoors to the shed for winter, for finishing on our standard 4 kilograms of concentrates, we grow to 1 kilogram of live weight gain per head per day, which is, to my mind, over 135 or 140 day winter is actually quite acceptable. And then some of those animals that are destined to go back to grass for a short extra grazing season, they're getting their respective silages and 1 kilogram of concentrates. They grew up 0.6 to 0.7 of a kilogram live weight gain per head per day, which is very, very nice indeed. And when they go back to grass for their short final grazing season, we got, I'm going to call it compensatory growth, where we get over about 60 or so days, we get 1.6 to 1.7 kilograms live weight gain per head per day, which is phenomenal. And then we take that onto the next slide, which is looking at the carcasses. So in the first grazing season, we're looking at the carcass weights for the grass clover and multi-species swards, and these are the average carcass weights for our 3 slaughter ages, because I'm trying to make the story simple for ourselves. So grass clover 384 kilograms, multi-species 386. To me, they are mirror images of each other. Likewise, the confirmation score on these carcasses were the same. And then on fatness, we saw in the first year, we saw an indication that the cattle produced on the multi-species pastures were somewhat leaner than those on the grass clover. We couldn't explain that, but we just noted. Then we come to the second year. I already said that performance on these pastures, performance for the year, because the weather conditions was particularly poor, so we have a lower carcass weight overall. This is the average carcass weight for the both pasture types, and they're both 329 kilograms each, so no difference between pasture types. Again, in terms of carcass conformation, it is what it is. They're the same. And in terms of fat scores, they were quite short on fat, but both pasture types were similar. Okay. Then we come to the other aspects of the work then. So in terms of, we thought, and it's been said that maybe there's a capacity for some of these newer swards to reduce greenhouse gas emissions. So from the period May to September, we had 40 yearlings that were being zero grazed on these respective swards. So with 40 yearlings, each day we went out and we zero grazed our grass clover and zero grazed our multi-species swards, brought them in and fed it to animals under controlled conditions. And we measured, using the green feed units, we measured greenhouse gas emissions. And we found that both pasture types had near identical emissions on those zero grazed grass, and that both had the same live weight gain as well. Likewise, from October to December, we switched the animals over. Now they're now almost a year and a half at this stage. We switched the animals over from the zero graze grass to the respective silages. And we again measured the greenhouse gas emissions. We found the same greenhouse gas emissions from both silages, and we got the same live weight gains as well. Then in terms of the parasite challenge, so the zero graze animals, initially they were indoors for all the summer. We dosed them for worms initially, and then sometime, having confirmed they were clean, we then dosed the animals with known amounts of Ostatagia to basically test when those Ostatagia larvae matured. They start producing fecal Ostatagia eggs, and they're excreted in the feces. So for the following couple of months, we measured the fecal egg output from the cattle, having been dosed with these worms, and we found that the egg output was near identical from both pasture types, suggesting that there was no evidence in our case that the multi-species swards had any anthelmintic properties, i.e. the same output was coming from both pasture types. And finally, we have taken, with our colleagues in UCD, University College Dublin, they've taken soil cores and soil samples to look at the vertebrate population, and we're still waiting on those results to come back. So then, to try to summarise the message, and apologise for the breakdown in the middle. So what are we saying then as the takeaway message? So in terms of the grazed pastures that receive the 0N, we're saying broadly herbage production is the same on both pasture types. In terms of the sward management, in terms of rotation length, post-grazing sward height, pasture covers, and so on, they're broadly the same. We had, as I said, 3 farmlets on the grass clover and 3 farmlets on the multi-species. Each of those were managed independently of each other, and almost throughout the full season, a day was at most was the time difference between the various groups moving. So by and large, we look at the same thing throughout. Again, for those of you who've been experienced with these type of swards, we're saying they do look quite different. And then during the presentation, I made the point that over time, the pasture components are changing considerably, and particularly in the multi-species where the herbs, particularly chicory, is decreasing quite rapidly. Having said all of that, even though these pastures look like chalk and cheese in terms of appearance, we saw that the actual DMD as what's offered to the animals is broadly similar. We recognise there's higher crude protein in the clovers, and we see higher minerals in the ash content in the herbs. That's what we saw. We also observed that the multi-species had a lower plant dry matter of the order of 2 to 3%, and we have certainly concluded from our work that the main drivers, the main tractor driver, the main engine drivers of these swards is the clover content. I go as far as saying they're the main drivers of these swards. Without clover, we don't have anything really. In terms of the silage production from these pastures, I said I took up the liberty in saying, by and large, taking 2 years together, they're broadly the same. But we did make the point in terms of silage making that the multi-species swards have a lower dry matter, so they would need extra wilting time, say, to get a sward up to, let's say, 25 or 30% dry matter. Might be an extra 12 or 24 hours, depending on the prevailing weather conditions. But having said that, we said both over the last 2 years and over our 2 harvests, both pasture types have preserved adequately well. And then, to summarise on the animal side, we're saying that within a year that we got similar live weight gains between the 2 pasture types. Admittedly, the 2 years are quite different, but the actual pasture type within year pasture types are broadly the same. So in year 1 and year 2, when we slaughtered animals at the same age, we got the same carcass weights. Conformation, by and large, the same thing. Conformation is a combination of, I think it's a breed effect, so it's not surprising they're the same. Carcass fat score, I said similar with a question mark, making the point that in year 1, we saw a leaner carcass from the multi-species. Couldn't quite explain why we didn't see it in year 2. In terms of greenhouse gas emissions, we click at Paul, we said that when the animals were offered fresh herbage as in zero graze, we got the same output of greenhouse gases. When these animals were offered these pastures as silage, we got the same output as well. In terms of parasite burden, I didn't say it up to now, but I'll say it now. So throughout the 2 years, we measured fecal parasite loads on the animals by fecal sampling over the season. And we simply observed that the level of the parasite burden was low and was similar on both pasture types. And then when we challenged the animals, if you wish, to be dosed with a known quantity of larvae, we found the production of eggs by these Ostatagia parasites the same on both pasture types. On maybe a broader part, we're interested in the whole nitrogen excretion and nitrogen balance from both fresh herbage as fed to animals and silages from these pastures. We're still awaiting the results from those, and we won't call that until we see them. And then on for the animal side overall, then we're saying that during the winter, then when we're fed these silages, I'm saying by and large, we're seeing broadly similar performance on both types of silage. I said the invertebrate part is waiting. And then the final comment is that there are a few challenges we might speak about later on if you so wish. And that is around the weeds at when the swards are being established, and maybe the introduction of cattle into some of these swards for the first time when bloat might be an issue. And the final slide thing really is just to acknowledge and thank people. So to thanks the Teagasc Wild Scholarship Fellowship Scheme, where both Sarah and Marie were paid for, our colleagues in UCD who are part of that scholarship supervision, our colleagues in Dundalk Institute of Technology who are very much involved in the silage making part of the work, and of course our colleagues here at Grange without whom we couldn't have done the work. So I'll thank you and apologise for the breakdown of my technical skills at this end, and hopefully we can take some questions if there's any to come. So thanks a million, everyone.
Thank you very much, Ed. Paul, if you want to unshare the screen, then we'll be able to see everyone. Thank you very much. I'll go to Sam first, as I know he put his hand up partway through. So if you unmute yourself, Sam, and then ask your question. Thank you.
Yeah, thank you very much, Edward. We've had a bit of experience with mixed species, as of two of the other guys online here. We were part of an EIP project, and we're sponsored to do mixed species work. We've on this farm have been at it for about 6 or 7 years now, and just a few observations that I have found. We couldn't return rotation to mixed species the same as our perennial ryegrass. We had to wait for 30 days instead of 20 days. We ended up getting a specialized fertilizer to put on our mixed species and our grass clover swords, 7N, 6.9P, 14K, 9 sulfur, zinc and boron, and that's dramatically increased the amount of clover we have on our swords. Persistency of chicory. We've stopped putting chicory in any of the mixed species swords because it doesn't last. We have fantastic crops of plantain, like fields of lettuce, and this is 6 years down the line. And finally, we don't make silage out of mixed species sward because it's too wet. We make it out of red clover, and that's the job. But thank you very much for your presentation. Particularly interested in the live weight gain and the possibility of less worms when we're using mixed species, because we have probably found that as well. Not really any question, but just an observation.
No, but I'll come back if I may. Thanks, Sam. That's helpful. So, indeed, you're right. Our rotation lengths were out to 25 to 30 days as well, and that was our plan. Simply because we said we're using 0N on the grazing area, we felt that coming around 21 days would be too quick for the system. So with a 25 to 30 day rotation in that first part of the season, so from April right through to August, and then
what stock was that at?
So we're turning out. So we're turning out in spring at 2,000 kilograms of live weight per hectare on the grazing area. That gives a demand per day roughly about 40 kilograms of dry matter per day, roughly in that context. Now we have nothing on sort of specialized fertilizer for these pastures. Like our own soil P and K index are pretty good. So on a scale of 1 to 5, we're probably 3.5 to 4. On most occasions, we're not bad. And our soil pH is 6.5, 6.6, 6.7. So I think we're reasonably good on that.
I think the mixed species really improves the soil structure, and that's what we have found. Our worm count has really shot up, and you know, it maybe not be as persistent at 85 pound an acre to sow mixed species. It maybe not be as persistent, but you have to be very careful with it. The clover and perennial ryegrass stick a lot more of abuse.
Okay, and I suppose the other point that, okay, you've seen the chicory disappearing as well under grazing, and you've seen plantain maintaining itself pretty well in your experience. Yeah, like in our case, I make the point we are grazing to a height of between 5 and 6. Our beef system generally operated at that level. We were taking the guidance from other people in terms of that these multi-species pastures should be grazed with more lax. So we've did that, but we treated the clover in the same format. So we treated the clover, both pasture types, as much as we could ever do it, are managed in a similar fashion. On the silage side, like your point is well made about using red clover. When this was done, we said we want to try and operate a system where we want to look at these things maybe over a slightly longer term, and we wanted to test the system. If we had these pastures and we made silage from it, were there challenges? And I suppose we saw some challenge in the beginning, and you make the point there in terms of trying to wilt these things is a challenge as well in poor conditions. But even in dry conditions, we say to take these multi-species, particularly if they're rich in chicory and plantain, there's probably an extra, I'd say 12, maybe more, maybe 24 hours.
Did you apply an additive to your?
No.
Well,
no, so
no. We have gone down the route of not, and now we have to on red clover because there's not enough sugar in the mixed species plant to have a good fermentation. And like our analysis for our red clover silage has jumped from a 17% protein to a 19 to 21% protein, just with additive.
Yeah, indeed. I think the slide I showed you there to the group for soluble carbohydrates concurs what you just said, that the two clovers are low in soluble carbohydrates, and they're important to kickstart preservation.
Yeah. Thank you very much, Edward.
No, thank you, Sam. Thank you.
Edward, we've got a couple of questions in the chat. So
sure.
Dale said that he thinks the multi-species sward was probably grazed too tightly for too long, and that's why the herbs didn't persist. I don't know if you've got any comments on.
Of course, I'll have a comment. Everyone's entitled to their opinion. Certainly, in a number of occasions around where other studies have grazed them much tighter than we do. So to me, the average height about 5.5 in terms of trying to get a balance between pasture production, pasture utilization, and maintaining sward quality. I think it's important. So our management system is we would top our pastures once. So in that rotation that starts to be in late May through June, we'd top our pastures once to maybe try and reduce some stimulus that's emerging, and we wouldn't top anymore after that. So we're trying to endeavour to maintain our pastures within reason under grazing conditions, and grazing more lax than 6 to me would probably lead to very patchiness of the sward, and indeed it may well end up have more selective grazing. Okay. I take the point someone has made. That's fine, but I would tend to contend that if we're going to keep our pastures in a condition that are leafy and green, we'd need to be grazing somewhere under 6.
Okay, thank you. A question from Nigel: would a longer grazing cycle have benefited the multi-species sward?
Okay, I don't know how far more you go beyond sort of 25 to 30 days. I think Sam made the same point to himself. To me, if we go beyond 25 days, you've probably got plants start to seed out and head out and so on. So if you go to 40 days, in that May into June, sward will go from being a green, leafy, vegetative sward to a sea of blue in the case of the chicory, and plenty of plantain heads looking at you, waving in the wind. So I really couldn't visualize in that part of the year, in that maybe the plants are transforming from being vegetative to more reproductive. I couldn't envisage a situation where it to be much longer than 25 or 30 days. That'd be my take on that. Now, I have no problem then coming to the second half of the season, maybe from July or August onwards, maybe, where we're trying to build up supply of grass into the autumn time, because once you come to September, you'll expect that the demand by the herd is going to exceed current grass growth rates. So we need to build up pasture supply, and that's going to happen under a longer rotation system. And that's what we try to do that August-September period, where the whole farm is back in for grazing. The 2 silage harvests are taken, and we're back in for our grazing. So the whole farm is available, and that situation then rotation lengths will extend. I hope that's answering the question somehow.
Okay, thank you. A question from James. You stated that you may experience incidents of bloat. Of the 72 cattle, do you know how many incidents of bloat required treatment?
I
And
can.
at what stage of the
Yeah.
grazing season?
Okay, I'll quantify it a bit better, and this is where the warning came to us. So when we saw the pastures in the first year in 2021 and are being established, the study was being set up. We in that September period into October, we put 100 weanlings onto these pastures, both grass clover multi-species, and it wouldn't be untypical for us to have 5, 6 or 7 animals bloated each day initially on those swards. And I wouldn't blame the multi-species any more than I'd blame the clover, but on both pasture types we were seeing that. That was a real, let's say, alert to us as an outcome. So then when we went into the first winter and thinking the following spring, we were really worried. We were saying, look, we're going to be in trouble here next spring. We've introduced these cattle to these pastures in March or April. To our surprise, we went out and we had no problem with bloat in that April, May, June, July, August period. And we saw the way the clover content of the pastures increased into August. It was only when we came to sort of late September, early October in both years, when the weather turned quite sort of, let's say, wet, the grass is extra wet and soft with a high clover content, that we saw increased incidence of bloat. So we had, let's say, 2 or 3 animals showing bloat. We lost none, but our strategy was 2 strategies. One was following what we saw in the first autumn. We installed a medication system just in case we needed it, or we could medicate the water. But we said we wouldn't use it for the simple reason that if we used medication and we had no bloat, that wouldn't be helpful to anybody because most farmers wouldn't be in a position to have a medicated water system. So we held it off. But during that first and second grazing season, from turn out until late autumn, we had no problem with bloat. It was only in that very back end of the year when pastures got soft and wet and soapy and sloppy that we saw cases of bloat. And what we did was, rather than medicating with, say, bloat guard or bloat oil, we introduced a small bit of straw, maybe a kilogram of straw per head per day, basically a small bale put under the electric fence wire every whole day. Cattle ate it to their own choice, and we got no losses due to bloat. Now, the worry I had then about this is that if a farmer introduces and makes a few fields of multi-species or grass clover on the farm as a test case, and the rest of the farm, as I said, doesn't have a rich clover component, I'd worry a small bit about cattle being introduced suddenly to that new pasture without having been exposed to clover or multi-species before. So it's in that context I would say it in the bottom of my slide, to first of all to remind me to say it and to recount what we experienced, but also to make the point that to have a small maybe flag in terms of bloat being an issue and to be aware of it. Not to frighten anybody, but to be aware of it, because when you see it, it can be quite dramatic. And if you go out in the morning with an animal blown up and the 4 legs up in the air, that's not a very nice thing to look at.
Okay, thank you. Sam, did you have a comment to add to that?
Yeah. Just you would never put cattle into a mixed species sward or a very clovery field in damp conditions. We haven't had a bloat case, and shouldn't say this, in 6 or 7 years. But if we thought the weather was a bloaty type of weather, we'll put a cup full of vegetable oil in the water clock. Just as simple as that. But what we haven't had any problem with bloat. And if you did, 10 mils of Betamax down their throat, and that's it. Started. Yeah, it could be a problem in some places. Yeah, I do believe that. Yeah, thank you.
No, thank you. Thanks. That's important. Thank you.
Thanks, Sam. Sean's got a question. I've been told in terms of bloat, if animals are not used to clover and then introduced to it, adding some vegetable oil to the water trough can prevent the bloat. So that's similar to what obviously Sam's just said. So thank you guys for that. Rachel, oil stops the bubbles from forming. So just like adding oil to fats to what in your washing up liquid. So thank you, guys. I've learned something new tonight. I've never heard that one before. I've got a question to ask. You didn't mention much about the soil structure and the difference in soil structure from the two lots of swards. Have you got anything to mention on how the soil structure, and obviously I shouldn't laugh and say about drought conditions, because we haven't really had much drought conditions.
So on the soil structure, these pastures were 2 years old. So I wouldn't be expecting anything drastic to emerge in the space of 2 years. But I would maybe answer another way by saying that maybe our colleagues in Johnstown, Castle and Wexford, who have been looking at maybe in smaller plots, these more complex pastures versus simple pastures, they would make some comments on the improved soil structure and drainage capacity that might emerge under these more complex wards. So they'll speak about maybe the population of earthworms and earthworm casts being higher on the more complex wards. That will be enhance soil water infiltration and soil drainage. They might also comment, which I'm maybe going on the tangent now, maybe in sort of maybe nitrous oxide emissions from some of these swards. They're suggesting there's lower emissions from these multi-species swards and grass clover swards. They're getting lower levels of nitrogen. It's not my forte, but that's some of the work that's coming through on that. What we'd love to have done, but we've got no funding for it, is we'd love to have installed ceramic cups under our pastures to try and capture their difference in nutrient leaching under these pastures. So we don't have that. Now our colleague here, Peter Doyle, has grass, white clover and red clover pastures, and he has installed ceramic cups. So maybe something might emerge in the near future on what's moving down in these soils under these conditions.
Okay, thank you very much. Has anybody else got any other questions? Oh, Rachel's got one just come in. Thanks, Rachel. When is the best time of year or season to do earthworm counts of wanting to build up a picture of all records of the fields? Okay, so I'd be referring to our colleagues in UCD who did the sampling. They came in springtime, and again, so it's in that say May, June period before the ground dried up, and also came in again in that September period. So there were two samples. Now, I'm sure I don't know any particular protocol for sampling other than that. I guess if you're going through a drought condition, you might expect many of the worms to be close to the surface. They might be retrieving a bit into their own burrows. So I can't say categorically, is there an ideal time? But so in our case, it was done in sort of a spring, early summer, when soils are moist, and again in the autumn time, when moisture began to replenish in the ground. Maybe others might know other better than that. Just had another question from Thomas come in, and he's planted red clover swards in 2024. He's relied on white clover swards. The red clover has been harvested for silage in late August and mid-September. His question is, he understands that red clover is not tolerant to grazing. Can the aftermath be grazed with lambs? And if so, how is best to manage this grazing? Okay, maybe I'll answer that in two ways. So the first part is that we have included, as many people do, red clover in our grazing swards. So we have, there are 6 kilograms of red clover in our multi-species mix. It has been grazed for the past 2 years, as I described, and it's been grazed tissue over to different cattle. And the red clover component is there quite evident. So so far in year 3 of it, where it's been grazed every few weeks, every month, let's say, it's still persistent. Or my colleague Nicky Borden and Jamie O'Driscoll have red clover pastures as part of the dairy calf to beef system they operate. And as someone suggested, they see their clover of the silage in the clover system coming from the silage from the clover system coming from red clover, but it's a red clover grass mix. And this must be year 5 or 6 that they have these clover pastures, which they graze. So they'll take 3 harvests during the year, and they're grazing the back end of the year with weanling animals. And they've been grazed successfully so far. And I'm saying we're into year 6, I think, of their production cycle, and they're still
a large quantity of red clover in those pastures. Now, they're not monocultures of red clover. Maybe if someone has that, it's a mixture. It's a ryegrass red clover mix. Is that fair, Paul? Paul Crossan, you might know as much as I do about that.
No, that's correct, Eddie. Yeah, I think the one of the main successes around red clover in Nicky's trial and also in Peter's is we're achieving yields of 18 and 19 tons of dry matter per hectare over 5-6 years. So exceptional yields, 3-cut harvest, and then a grazing at the back end, all working very, very well. Great yields and good animal performance on it as well. Obviously, intakes are slightly higher, but animals performing well.
Okay, thank you. So looks like other people are saying light grazing and don't mow it too low, otherwise you'll quickly eradicate it. So handle with care, I think, is the answer there, Thomas. Well, thank you very much, guys. Thank you very much for sharing with us your expertise this evening. I will share the recording, as I always do, afterwards. But thank you very much for your time this evening, and thank you everybody for listening in and catching up with us. Next week we have got one which is specifically for sheep, which we haven't done many of those. So future-proofing your flock and strategies for reducing emissions in sheep flocks. So if you'd like to join us next week and you haven't signed up, then do let me know. That's with Poppy Frater from SAC. And hopefully we'll see you next week. So thank you very much and enjoy the rest of your evening. Thank you very much,
Thanks,
guys.
everyone. Thank you. Thank you.
Thank you. Thanks,
Cheers.
Edward.
No, thank you very much.
Thanks, everyone. Bye.
Thank you. Bye-bye.